Next generation of Intel Core 2 and Xeon processors builds on the success of our revolutionary Intel Core microarchitecture and marks the next step in Intel's rapid cadence for delivering a new process technology or an entirely new microarchitecture nearly every year. Intel has achieved the biggest breakthrough in transistor technology in 40 years through the use of hafnium-based high-K and metal gates in its 45-nanometer silicon process. This allows us to continue our leadership in performance and energy efficiency improvements. Compared to 65-nanometer technology, Intel's 45-nanometer high-K metal gate silicon process technology will provide approximately twice the transistor density, a 30% reduction in transistor switching power, a greater than 20% improvement in transistor switching speed, and a reduction in transistor gate oxide leakage greater than 5 times over previous generations. The overall result will be new opportunities for greater performance and greater energy efficiency. The first family of processors based on this new 45-nanometer silicon technology makes good use of the additional transistors Intel can pack into a chip by delivering innovative architectural features and advancements that make software run faster and further improve energy efficiency. This new family will feature dual-core mobile processors, dual and quad-core desktop processors, and quad-core workstation and server processors. For enhanced performance, the 45-nanometer-based processors include new Intel Streaming SIMD extensions, or Intel SSE4, the most significant media instruction set architecture advancement since 2001. Intel SSE4 will enable microprocessors to deliver superior performance and energy efficiency to a broad range of video, media, imaging, and high-performance applications. The performance gains can be dramatic. For instance, the Intel SSE4 streaming load instruction improves the bandwidth for reading data from a graphics frame buffer, fetching a full cache line, 64 bytes at a time as opposed to 8 bytes, enabling up to 8 times theoretical improvement in read bandwidth performance. Penryn microarchitecture improvements also include a new Super Shuffle engine that significantly improves performance of many SSE2, SSE3, and SSE4 instructions, and doubles the speed of many SSE data shuffle operations. This full-width single-pass shuffle unit is 128 bits wide and performs full-width shuffles in a single cycle. More performance gains are realized through a larger, enhanced Intel Advanced Smart Cache. 45-nanometer-based processors include a 50% larger L2 cache with 24-way associativity to further improve the cache hit rate and maximize utilization. This increases the probability that each execution core can access data from a higher performance, more efficient cache subsystem. A new divide architecture called the Fast Radix 16 divider enables processors to provide faster divide performance, roughly doubling the divider speed over previous generations for many computations. Radix 16 accelerates division in both floating point and integer operations approximately 2 times, and square root calculations up to 3 times, significantly accelerating scientific computations, 3D transformations and rendering, as well as generally mathematically intensive functions. Other enhancements making their first appearance include higher core speeds, greater than 3 GHz for some versions, faster front-side bus speeds, and enhanced Intel virtualization technology. For Penryn mobile processors, Intel builds on the already significant energy efficiency capabilities of the Intel Core microarchitecture with 2 important new advances. The first, Deep Power Down technology, is a new advanced power management state that significantly reduces the power of the processor during idle periods, making internal transistor power leakage no longer a factor. This helps enable extended laptop battery life and enables a substantial improvement in efficiency over previous generation Intel mobile processors. The second advance is a key enhancement to the Intel Dynamic Acceleration technology, currently available in Intel Core 2 Duo processors. Intel has enhanced this feature to enable better use of the additional power headroom freed up when a core is made inactive. By boosting the performance of a still active core, this technology speeds up the performance of many single-threaded applications. With desktop, mobile, workstation, and server-optimized versions, there are plenty of ways to take advantage of Intel's continued industry-leading performance and energy efficiency. Through this enhanced version of Intel Core microarchitecture and our first processors made with 45 nanometer high-K metal gate silicon technology. Take advantage of the next step in Intel's tick-tock product strategy and cadence through the 45 nanometer based Penryn family of processors coming in the second half of this year.